Observability 2.0, more than logs, metrics, and traces, with our guest tonight, Neel Shah. Hey, Neel, how are you doing?
Hey Chris, I'm amazing. Thank you for calling me here.
Thank you so much for. Full disclosure for everybody that doesn't know, I'm terrible at time zones. And when Neel first talked to me about this, I said, okay, when do you want to do this? And he said, I want to do this. I gave him a couple of different time options. He picked one, and this is not that time option. So I got him up way too early. And Neel, I'm so sorry. I am bad at time zones, even on the best of days. And yeah, it's been a tough week. So thank you so much for coming on
No
7
worries,
a.m.
no
your
worries.
time.
Due to this, I wake up early and it will be a good day for me then.
Right, exactly. So I'm up late. You're up early. We're gonna make it. We're gonna have some fun with this. So for the audience that doesn't know who you are, would you like to introduce yourself? Why should people
Yeah,
listen to you about observability?
yeah. Because I've been observability advocate and have been helping a lot of different companies in observability space. And majorly, I am a community guy, DevOps community guy. I used to run the Google Cloud's HashiCorp chapter in my local region and helping out people a lot of different spaces and hosting different events, roundtables, and a lot of different stuffs around that. And
Hmm.
helping people in hackathons to build cool projects and have been mentoring 15 plus hackathons this year and also have given sessions in KubeCon, PlatformCon, and different conferences to aware people about the latest trends in DevOps, AI, cloud around that.
Amazing, amazing. And so one of the things when you and I first started talking about this conversation, observability is a extremely important aspect of DevOps, of course, but it's one that historically hasn't gotten a lot of love for a better term. And we're going to get into this with the talk and everything. But are you seeing that changing now? Are people giving it the love that it deserves?
Yeah. So because there are a lot of downtimes. If you see in recent time, so a lot of big companies have downtime. So
Hmm,
actually impacted a lot of business. So
right.
because if you see a single product is down for at least a day, then it is $1 million loss for a company. So nowadays people are adapting a lot of observability tools, and nowadays is AI is also evolving in observability. So there are a jam of AI plus observability, and people are using that because it helps them to automate a lot of stuff around that. And people are shifting now because if you see the market in 2026 of observability, it's around $10 billion.
Yeah.
So a lot of different companies are here and a lot of because data is important, and eventually if you want that your application performance should be better everywhere. So a lot of people, a lot of companies are shifting out to observability.
Yeah. And we're kind of seeing that on our side too. And I will say that from the perspective of observability, I am appreciating machine learning and artificial intelligence, like being able to feed a metric ton of logs into a system, and then having it just spit out like the couple of parse through it and quickly get me to the root cause analysis, and then also give me a couple of remediation steps. That's been pretty big, and honestly, I kind of think that is one of the reasons why monitoring is it's always been a little bit tough to, like, go through logs and stuff. So anytime that we've had something make it easier for us,
Mhm.
it's gotten easier. So I think that's why this is kind of like a big moment. Um, okay, cool. So do you
Yeah,
want to share your
absolutely.
screen? I'll add it there. Oh, look at that. Nice.
So hello, welcome everyone. Thank you for joining us today. So let's understand Observability 2.0, how it is different than the log metrics and traces. So yeah, here's a small introduction of me. I already shared it before. So I used to organize Google Cloud, CNCF, and HashiCorp chapter in my local region. I'm also a HashiCorp ambassador and have mentored more than 15 plus hackathons and have given talks in 10 plus conferences last year, including the KubeCon, PlatformCon, GopherCon, spike on different conferences. So starting with agenda of today is how the evolution of observability has occurred, the OpenTelemetry's role, reducing downtime with OTel Collector, ML and LLMs in observability because AI is there everywhere, how we can optimize the observability cost, what are the AI-driven future, and what are the key takeaways from the session. So let's see the evolution of observability. So Observability 1.0 was there in around 2015, where introduction of Prometheus and Grafana, tools like that happened. But around 2020, a lot of shift from monolithic to microservices happened, and due to that, a lot of tons of logs and matrices occurred, and there was an explosion of telemetry. So it was a boom of telemetry, and then it was there in 2023 that AI came, and a lot of people started adopting AI. So nowadays, using AI, there are a lot of anomaly detection, predictions in observability space, and people are utilizing that because it helps them in a lot of root cause analysis and different stuff. Next is consider a scenario that it's 2 a.m. and your production system is down. You are flooded with millions of logs, and you don't know what to dig in.
It's 2
So
a.m.
yeah. So it's a correct preparing. So meanwhile, so the application is down for some time, and customer feels that why it is down, why it is not working, and it's a business loss. So instead of that, if we have a predictive system that there are chances that it could be down or something like that, there are chances of issues or errors. So we want that. We don't want to firefight that. We want to force it because it is very hard. If you talk with a lot of DevOps or SRE, troubleshooting in production is hard. But if you have proper setup, but it is easy. But when it comes to tons of logs, it is really hard. So now imagine a better system. Your observability system detects the anomalies early. It flags that Neel, there could be some spikes or some issues or some errors, maybe in the next couple of days. So it is pretty good because we can be better fitted that it will be down, so we can have understanding of that. Like we can prepare for that, and we can act accordingly and avoid the incident together. So it's a better situation. So if you don't want to go at 2 a.m., do this. And I will also see how we can do that. That's a image I just created with that. So if you don't want to go on left, do the right one. So enhanced capabilities and how the observability has occurred and how the correlation and contextualization occurs in observability is it automatically relates the data from the front end to back end because data should be correlated. Next is AI anomaly detection. If I just gave a brief about how what is anomaly is, so consider a scenario where a normal graph is going on and it is predicting that from like last couple of 7 or like let's say 7 days of gap, 7 days of data, it will predict that next couple of days what will happen. So you understand better that there should be some good spikes or some bad spikes. So traffic could be increased or something like that. So anomalies for that. Next is accelerated root cause. So root cause is a thing where observability comes and observability really helps. So using AI now it is very easy to do the root cause and also create a whole case study of that. In DevOps field, what we say is when any issue occurs or maybe a downtime occurs, we do a postmortem of that product. We do RCA. We create a case study of that. So it also helps the and real use cases are like detects database bottlenecks. So which point it is taking more time or which point it is not working or something like that. Next is evolution of observability. So observability has evolved, but there are also still challenges. A lot of challenges are there. So there are siloed data sources, siloed are segregated data sources, and even a lot of companies also do manual root cause. manual root cause sometimes is pretty hard. As I gave an example that it's 2 a.m. and you are big with tons of data and growing telemetry volume leading to higher cost and complexity because nowadays you see a lot of microservices are there, a lot of services have been created, and so each and every service they have separate logs, so they will be fitted in the observability tool, maybe in your storage or somewhere, so it can eventually increase the cost. We will also discuss the solution for this. So observability 2.0 today is unified telemetry with open telemetry. I will share more details on open telemetry. It's one of the biggest CNC projects. And next is proactive anomaly detection using ML models. Predictive insights, not just dashboard. We don't want to monitor that. We want alerts properly. We want
Right.
to understand it properly that we are in a better situation. And is cost optimized data pipelines. So if you talk about observability now, so OpenTelemetry is the backbone of observability. So OpenTelemetry is one of the second most contributed CNC projects backed by CNCF, and it is a vendor neutral open source product. So you can use with any of the framework, any of the tool, and every observability platform currently is based on OpenTelemetry. So give me let me have you understand like how OpenTelemetry arise and how it has helped. So before OpenTelemetry, let's say Chris and I was working on some application, and Chris wanted to share their observability data with me, but the format of that was different, and my understanding was my format was different. If you consider a different companies, all the format were different. Then OpenTelemetry created a good framework and have like the proper formatting of that, all the data. So it's a standardized, and if anyone wants to share data with any other platform or maybe company, they are easily shareable. So created a whole platform, whole framework kind of that, and because it created easy and it's fully open source, you can see that.
Yeah, it was really frustrating because every vendor had their own proprietary format, and if
Yeah,
you were trying to like share from one company to another, forget about it.
yeah, true. So you can see the GitHub repo of OpenTelemetry, and a lot of people contributes over here. And nowadays, you can also see a lot of demos around AI because they are also evolving AI. So why OpenTelemetry matters is I already shared that unified standard instrumentation and easier correlation between signals. Signals are logs, matrices, traces. So these three are different types. Logs are the application log, infrastructure log, different kind of the log. Metrics are the dashboard which you see like spikes or graphs or something like that. And traces are the whole user journey. The user journey is when you had came on an application, maybe let's say an e-commerce application, and you are going to any product and done the purchase and order that, have completed the order. So it's a whole user journey. So if I want to see your whole user journey, then I can see your trace. The trace has a whole user journey. So these are three different type of signals, but they are also relatable within in between each other and extensible with processors, filters, and exporters. So processor, filters, exporter, I will see like how the open telemetry architecture is. The impact on observability is reduce engineering efforts on monitoring setup because as I told you, if I want to change to another platform or maybe tool, then it is a mess up for me than putting off all the efforts here. And it also forms the foundation of AI observability systems, AI-driven observability systems. So hotel collector. So OpenTelemetry has the main component as hotel collector. So it has three main components. That is receiver, processor, and exporter. So receiver receives data from your application through via agent or something like that. Processor manipulates all your data in a fixed format, and then exporter exports your data to any other vendor or any other tool. So it is a complete full kind of platform where the major three components are receiver, processor, exporter, and it can help you out. If you want to see more, and then you can scan them, and it will be our whole detailed blog over there. So yeah, here comes ML and LLMs in observability. How we can forget AI in an observability space. So one thing is it detects anomalies across your matrix, logs, traces, because in matrix is pretty easy. You can see spikes or something like that. But logs, so logs also have numbers. So consider a scenario where in 7 days you only have 3 to 4 error logs. Because logs are also good numbers. So if you only have 3 to 4 logs of errors, then you can also predict that you may have like 5, 6 number of errors maybe in 6 days or a couple of days. It's all up to like which kind of model you are using on backside. And next is how much data you have fed to it, because you need to feed your past 7 days or maybe more than one month data to the model, and then it will predict that. And nowadays, if you are using any, let's say, paid SaaS-based platform of observability, then they directly generally give this as an inbuilt tool or inbuilt feature. Next is prioritize incident based on severity and impact. So here comes the AI alerts. So alerts, like see, we have kept a lot of alerts, but not all the alerts are that severe. So if there are filtration properly and there is an AI which says that these are the most critical alerts you need to like take a look at that, then it helps a lot, because with logs you will have a lot of alerts also, but not all the alerts are important for us. So LLMs help you to summarize incidents in human readable language, and it also helps you to do faster and also it also predicts some of the data from the historical patterns. So LLMs and ML correlate that, and it helps you a lot. One amazing thing that I will share is if you know LLM Observability, then there are some tools, open source tools like OpenLit. So consider an application where you are using a lot of different LLMs, more LLM models. If you are using, let's say, if we had fed one request to one LLM model, and then it is calling another LLM, and it is calling another LLM, and the output is coming out. So it's a complex system. If you want to see which LLM is using how much tokens and it is costing how much, like how many rupee or dollar, then you can see whole dashboards like that. You can also see the whole traces of that using tools, open source tools like OpenLit. So LLM observability is now also entrenched. So ML and LLMs are transforming observability from passive monitoring to intelligent problem solving monitoring, because it is helping a lot of intelligence to your monitoring. So it is pretty much good in recent times. So key data types in Observability 2.0. So in 1.0, people were just seeing that logs, metrics, and traces. But in 2.0, we are seeing events. So events are discrete concurrences of maybe user clicks or transactions. So we consider a lot of transactions in nowadays observability space. Next is profiling. So profiling is as the snapshots of CPU, snapshots of memory usage. Next is dependencies. So how the services are correlated with that. And eBPF leveraging. So eBPF is also a good baseline in observability space. Consider a scenario where the OpenTelemetry is the base, and on top of that, eBPF have been a protocol of that. And a lot of companies have adopted eBPF based observability tools in recent times. So here is a comparison of how the Observability 2.0 has changed in each and every aspect. Maybe log, traces, root cause analysis. So log collection previously was manual, now it is automated. Log analysis was static searches and it was taking a lot of time. Now it is AI-driven searches and it is very much faster. Correlation was limited previously and now it is actually unified and it has a lot of things. So trace instrumentation is so we want like nowadays there are distributed traces. So if you consider a distributed system, similarly there are distributed traces. So now it is a lot of comprehensive and simplified instrumentation of traces. Root cause analysis was manual and it took a lot of time previously, but now with automated AI systems, we are doing it pretty pretty much fast. But as a lot of logs are coming out, observability cost has exploded. So storing every log matrix traces is not important because it it's to it gets stored, it consumes a lot of data storage, and then we are charged. So what are the different scenarios that we can do instead of storing all the things? And so the key cost drivers are high calendary metrics, repetitive logs, and oversampling of traces. So these are the main cost drivers for the explosion of the cost in observability. So the result is increased infrastructure spend, and it can slow down your queries. It can impact on your performance, and it is not manageable because the data which is not important in observability space we call it as noise, and it is not important with us. So with cost optimized strategies, observability becomes financially unstable. So here comes the smart data pipelines for observability. So smart data pipelines are systems that selectively process, filter, and enrich telemetry data, which is important for us. So in middleware, we have like ingestion control pipeline. So that helps you to remove all the unnecessary logs before storing out that with just a regex. You just give a regex and that data won't be stored from in your S3 bucket or any storage. So this kind of small feature really helps because it cut down a lot of cost for the company, and even it is pretty much easier for you to trouble down on in the logs. Next comes what are the key strategies of data pipelines. So dynamic sampling capture only a representative subset of data during normal operation. Deduplication because a lot of relevant and duplicate logs are there, so it can deduplicate that and it can remove that. Next is aggregation. So aggregating a lot of data in a single compile and then storing out that because that can also help at some position. And next is edge processing. So initial data reduction will be happen and then it will be stored in the source. So what are the benefits? Major reduction in storage, processing cost, and higher signal to noise ratio. Signal is all your coming data to noise, and noise is a lot of irrelevant data. Next is scalability to handle growing applications ecosystems, AI and future of observability, how AI-driven observability trends occur. So I told about like we used to set a lot of alerts, but there should be a lot of predictive alerts, and it should also show suggestions to us that this will be a solution for this alert. Next is self-healing system that automatically triggers out the recovery. So we all know how serverless works is. So if we need more CPU, then it gets more CPU for serverless. Similarly, in observability space, if we have a alert that your CPU utilization for this application and these services is consumed more than 90%, then it should directly spin up another VM for that, another storage, like another compute for that, and it should not be down. So this kind of systems, self-healing systems, are nowadays carrying out. And next is AI-assisted root cause analysis. So nowadays, in observability tool, there is because observability tool has all your logs, metrics, traces, so it has all your data. So it knows where the error has came. So it will. So nowadays there are chatbots in observability system where the answers of their errors will be shown. And if you see, because if you see as a manual that the answer is proper, then you can just apply. It will do a PR for you in your code because it already had access to your code and do all the things. So these are the things that are really going on in this system. And emerging innovation is dynamic telemetry pipelines that adjust the data flow. LLMs that automatically generate incident reports because if you see, uh, any downtime or errors or issues, big issues in your company, then we need to submit a lot of incident reports so next time it doesn't happen. So LLMs also help to create that. And autonomous observability is system that monitor, diagnose, and fix themselves with minimal manual human intervention. So here is the future of observability back in 2025, but now it is also implemented moreover in 2026 is one is cost management, AI-driven operation, AI integrations in observability space, full stack observability. Full stack is like it's not just for backend or front end. It's a combine of whole application. A lot of automation, a lot of AI workloads, and OpenTelemetry is there. OpenTelemetry is big. You should already see and understand observability from their perspective. Yeah, it also outcome from the fast recovery from the incident report, like, and engineer focus on instead of manual things, it can do automation. If you want to see a detailed blog on Observability 2.0, I have written there and the blog here, and you can scan that after later. And yeah, that's the end for me. I just wanted to have a brief understanding how Observability 2.0 has changed from previous thing, and hope it helped you a lot.
Cool. All right. So I have several questions. Hold
Yeah,
on. Let me. There we go. Hey, Shala, how you doing?
Hey, can you hear me?
Yeah, we can. Yeah, we can hear you fine. Are you in a new setup?
Yeah, I keep re-changing my setup. So
Do you actually change the desk to the other side, or are you mirroring it and it looks like you've flipped over the sides? I can't tell.
no, I like flipped the desk. So yeah, it's different.
Oh,
I
wow, you
move
moved the whole.
stuff to different sides.
But Gifted Lane shows. Is that showing up backwards or is that showing up forwards? Oh,
Is it
we'll
showing?
talk about it later. Never mind.
Okay.
I was just sorry, Neel.
Go ahead.
Shala came on like about 3 seconds after you started talking, and she was like, "Let me in the show." I was like, "Yes, ma'am." So Shala, Neel, Shala.
Yeah, hi, how are you?
I'm good. How
So
are you?
Shala and I
Yeah,
are both very, very deep into the observability side of the DevOps stuff. So I've actually got a couple of different questions that I wanted to get answered, both from the audience and from myself. Okay, from the top. When you have been using different LLMs to parse logs and stuff, do you have one that you like better than others? Like, is Quen better than Mistral, or do you have like a sense for which one operates better for this kind of work?
yeah. So when doing a root cause analysis,
Mm.
so there are different things. When we feed logs, so it will have a like thinking model. So there are different 2 3 processes in which different model works better.
Oh,
So there is
okay.
one thinking process. Yeah. So for every process, we use different models. We have tried different models, but I won't name one because a lot of people have a dependency. Like it is better for me. So I don't want to be in a controversial space. But so there are 2 3 different processes. So one is it will be a research mode. First will be research because you have fed a lot of errors over there. Next is it will generate code,
Mhm.
fix for that. Then
Okay,
it will give a fix it will think on the errors. It will give a fix of the code. So there will 2 3 different process and 2 3 different models work on that. If you rely on the
gotcha.
single model, the single model is not beneficial for the whole thing. Doing the
Okay.
thinking, doing the applying the fix and kind of thing.
Okay, so play with it, but like use Quen for the coding bits and use something else for okay, I got you. Cool. Okay, so if somebody is leveraging, okay, so one of the things that you talked about was like the large context window, and this was before you talked about dynamic sampling. So I wanted to ask about like context windows, and I think dynamic sampling actually answers this question, but I wanted to ask you with because in the observability space, you need to have a body of knowledge about how things look in steady state. Like you want to see how everything is appraising normally and logging normally before an event happens, so that you can know when what bad looks like. That would, in my brain, make me think that you need a large context window in the LLM to see what good looks like, and then to afterwards see what bad looks like. Doesn't that chew up a lot of tokens? I mean, is that expensive, or is that what dynamic sampling fixes?
Yeah, dynamic sampling works here. And another thing is anomaly detection. So predictive anomaly is also there, which helps you out a lot of spaces.
Okay.
So predictive anomaly is something like that. See, your graph is going proper, but if you share your past couple of days, like let's say 7 day of data with that model, so it's not on LLM, but it's a complete different thing of AI ML thing. Where if you consider a SaaS platform, they have that inbuilt feature of this. But if you go for open source, then you should use some open source tools and then train with your data. So what happened here is you feed your last couple of data, and then it will predict that
Mhm.
there are some chances of spikes or something like that.
Okay. Shala, I don't want to bogart the mic, because I'm a VROPS guy from way back, so I can talk about observability
Hope,
for
hope it, hope, hope it
for
helps
days.
to understand that.
Yeah, no, it totally does. Shala, I have more, but if you got some, please step in. Don't.
No, you're doing good. I am a little fried from work. Not gonna hold you. But
Oh, okay.
for me, one of the things one of the things that jumps out, I'm a little off hands on keyboard these days, but I haven't stepped away from it long enough to forget things that I'm definitely interested in. And what I think will be great is, how we were talking about like future and like AI stepping in. So yeah, things like where it can have like self-healing, where use the logs and see like, there's what the problem is, and then actually start like fixing itself. That would be awesome. The other thing that I care about that would have made my life easier were things like being able to quickly separate noise out of the logs, so you could quickly spot like, okay, what's the problem, what's the issue, and actually start working it. So that's what I'm really looking forward to and excited about. Anytime I'm talking to various things where they're telling me about their AI tools and what they're working on, and they start touching on monitoring and observability, those are always my things where it's just like, how does it get me to solving the problem faster? And I feel like companies are still trying to figure that out, and how they can get AI to start doing those things. That's when I'm going to be super excited, because Mike made me dive really deep into monitoring and observability. I never wanted to go that path, but I ended up in that path and fell in love with it. So that's
Isn't that the
something
way of
that's
it?
like super important.
Nice. Cool. Okay, so let me hold on before I ask. I get too excited about this, and then I forget that we have other people that are watching the show. So let me double check. Okay, no, we're good. Awesome. All right. So one question around. So dynamic sampling sounds really cool, but one of the things that I know just from my own experience is that in certain types of environments, when the variability of your environment is too great, getting sample sizes condensed down is sometimes a challenge. Where does this not work? Like, what kind of edge case solutions does this not work for?
So this kind of data doesn't work majorly with the fintech companies, because fintech companies don't want that any of their data. Maybe like, let's say it's not relevant. Maybe it's not. It is like noise. But
Mhm.
fintech companies have this kind of systems in an on-prem, and they want that because so if you see a lot of fintech companies, then they deal with a lot of compliance, a lot of legal compliance kind of thing. So in this scenario, they want that all the data should be there, even if the noise is there, they will store that, and because even after some time, they want
Oh, I
that
see.
it should be there.
Okay,
Yeah,
so but it's not because it doesn't work. It's because they just want to hold on to all of that data because they don't care if it costs a lot to store it.
yeah,
They because of compliance, they need to just hold on to all of that stuff regardless.
yeah. Because I had
Sometimes
talked to a
you
lot of
have
fintech companies in
compliance.
India. So
Oh, sorry.
okay,
No, I was gonna say like what I've witnessed is sometimes you definitely have compliance, and so there's regulatory rules where it's like I gotta hold on to this, and then sometimes it's just straight up hoarding data because they're afraid like the moment something happens, they're like, but we deleted it, and I knew we should have kept it, and so they just keep everything forever.
yeah,
That
yeah.
one EBS volume from 7 years ago. No, we can't get rid of it. Oh, come on. Yeah, we've been there. We've totally been there. Awesome. Cool. Okay. Let me double check. Like I said, I could nerd out about observability all night, but Shala, the other thing that you weren't here for that I screwed up on is I got the time zones wrong. So Neel got up early for me because I'm a monster, and so I'm not going to keep him longer than we have to. So Neel, thank you so much for coming on. This was a great talk. If people want to learn more, hold on. You actually had it up. If people want to learn more, what was
Yeah.
the link to your blog again? There we go.
Yeah.
Middleware.io Observability 2.0. Okay, I will put that in the link to the show notes so that everybody can have that knowledge for them to check out. Amazing.
Yeah. And if you want that, you can also reach out to me. I can also help you out on LinkedIn.
Yep, we're going to have all of your contact information in the show notes for the episode, and I'm going to let you go so that you can get on with your day and get a cup of coffee. Once again, I apologize. I'm a monster. All right, everybody.
You have a better sleep today.
Thanks, Neel. I appreciate it. Everybody, have a wonderful night, and we will see you again next week.
Bye.
Bye.
Bye, everyone.
Later.